My name's Kevlin Henney. I'm here to talk to you about failure. To be precise, I'm going to talk to you about learning from failure. I think we're all familiar with failure, but the real trick is, can we learn from it? So I'm an independent consultant. I'm based in the UK, and I have an interest in failure. In fact, my name is associated with failure, which is something that I will let's talk about it and see what we can learn in this time. So you can find me on a lot of different social media. Pretty much it's Kevlin Henney, some variation thereof. And I mentioned my name was associated with failure. So let's see how this plays out, because it's very much this thing that on Twitter and other social media platforms, people take pictures of screens and they will tag me in it. And these are sometimes known as Kevlin Henney screens. We see this one. These are often just either blue screens, or they are obviously very directly coding failures, like this one. Not sure if I'm time traveling, but pretty sure there's no -1 a.m. or -1 p.m. And then people ask me, does this count as a Kevlin Henney? Now, the thing is that sometimes people look at this and they go, well, wait a minute, what's a Kevlin Henney? People will just see this on X or on Blue Sky or something like that. And it got to a point recently, I thought, you know what, I am going to write an FAQ. I'm going to write something on my blog. FAQ, what's a Kevlin Henney? Recent events. That recent event is CrowdStrike. I'm going to mention CrowdStrike in this talk. Have prompted me to finally write up an answer to what is perhaps one of the most frequently asked questions I receive online and face to face. The question is normally of the form, what's a Kevlin Henney? Or what's a Kevlin Henney screen? Or why do people send you failure screen pictures? So that's my most recent blog posting at the time of writing, but you can find it very easily, kevlinhenney.medium.com. A definition was actually posted by a number of years ago, 2018, by Hadi Hariri of JetBrains. A software failure that happens in some public space, for instance, an airport flight information screen that has crashed, or an ATM that displays a reboot message. The thing is that people have been atting me with these for years, and I have taken to retweeting them. And sometimes I will include them in my talks, and sometimes they lead to some very interesting discoveries. One of the most recent interesting discoveries, just a few weeks ago, to do with quantum lock. So, this is an interesting kind of failure. What we're going to do is we're going to try and learn about what we should think of as software production practice through other people's failures. So this was a news item that appeared on Steam late last month. Quantum Lock shutting down purchases. So Quantum Lock is a game developed by Fat Bomb Studios in New Mexico. I think it was developed 2015, 2016, so it's kind of old. It's about 8 years old at this time. Specifically, Quantum Lock shutting down purchases. This game is being discontinued. Hey, everyone. Quantum Lock was our first game, and although it was a big milestone for us, it was created at a time before we understood version control software. Don't let this happen to you. It's your product. It's 2024. Just for reference, the first source code control system was developed in the early 70s and made more widely available in the late 70s. This is old tech. So the point here is a piece of advice that we keep seeing people repeating and repeating. And it's just one of those things that is always worth keeping in mind. Now, a number of years ago, I edited this book, 97 Things Every Programmer Should Know. And a lot of the content is freely available online. I made sure the license for the book was open source. This is it. Put everything under version control. A piece of advice from Diomedes Spinellis. But this is important. Don't just put your source code. So that's the first thing. Definitely your source code, and definitely take backups. If that's the baseline. Take backups, but put everything under version control. Your source code. And we're going to see what source code also includes, but I'm going to include here every project asset that you've got. If it's to do with your product, it gets version controlled. You got documentation, version control it. Okay. You've got configuration details. You've got build scripts. You've got deployment scripts. These should all be versioned. Okay, you've got binaries being generated. Yeah, version your binaries. Do not presume that you can regenerate what happened in the past. If somebody gives you a bug against a particular version, have that version. Don't try and recreate it. You'd be surprised how difficult that can be. Now, sticking with the games industry, here's another one. This was also this year, EA Games. And yeah, I'm sure everybody's heard of EA Games. It's one of the largest games companies in the world. So, they've obviously got a really robust um, software development process, you'd expect. So here's a message. We are aware of an issue on console in which the game may crash on startup. This is currently being investigated and will be fixed as soon as possible. Let's just notice the date here. 29th of February. This year was a leap year. Here's the fix. Guidance for PlayStation players. On your console, go to Settings, System Date and Time, Set Date and Time, Set Manually, change the date to March the 1st. Once this change has been done, the game should function normally. So here's the thing. This is just basic common knowledge. There are leap years. Somehow somebody overlooked this, but they specifically overlooked it because the first thing you need to know is that pretty much every programming language and every standard library has date and time functions. They vary in their quality, but in terms of quality of usage, but they are generally correct. Do not assume you can write a better version. Okay. So in other words, somebody at EA Games, I'm going to presume that it was written in C or C++, this code. And yes, the C and C++ libraries do have standard access to date and time facilities. Do not reinvent the foundation standard libraries unless you have a very good reason. And if you're going to do it, yours had better be better. And the only way you're going to know it's better is if you test it. So, okay, really basic stuff. Test it. And time is a dependency. You test your external runtime resource-based dependencies. You mock them out. You test against files. You test against network connections. You test against databases. Time is an external resource. Please, please do not write your code so you actually just take the time directly in a statement of your code and just pull it out of new date or datetime.now or anything like that. Please don't do that. That is not a good practice. You pass it in, or you have a time provider, which we could call a clock. Because if you're going to write it, then I presume it's going to look something like this. Okay, is leap year, and technically this is what EA Games would have done. They would have hard-coded it to false, except they forgot that there were leap years, so this is their implementation. But let's imagine that it was like this. And if it's going to look like that, well, obviously it's wrong. Most people think this is the correct definition of a leap year check. Okay, everybody thinks, or most people think, that every 4 years it's a leap year. This is not true. So this is the other thing. If you are going to rewrite something that you think is trivial, look into it. Yeah, look into it. Just check. This is the actual Gregorian rule that is used in all current standard calendars. Okay, it's only been around for a few hundred years. We should probably have the hang of it by now. But if you want to, so basically for those who want it translated into English, once every 4 years with the exception of every 100, unless that is also 400 years. So 2000 was a leap year, but 2100 won't be a leap year. If you want to generalize it properly for all calendars, actually that's a lot harder. That's going to take you months to get it right. So the key point here is, please use your standard library. It's there for a reason. If you want to produce something better, demonstrate that it's better. And that involves testing, and that also involves a bit of research. So this is a book that I finished with Trisha G. At the beginning of, well, the first wave of lockdowns in 2020. 97 things every Java programmer should know. And one of the pieces I contributed to this was name the date. And I make this observation. The most obvious lesson is that date time handling is harder than people expect, even when they're expecting it. And that's a key idea. It's always going to be harder. There's a reason most things are in the standard library. Reuse other people's work that you know already works, unless you have a good reason, and you better be really good. So let's talk about things that go boom. Ariane 5, the maiden launch of Ariane 5 in 1996. Ariane 5 has proven to be one of the most reliable launch systems historically. European Space Agency, it's fairly heavy lift vehicle. It has launched so many satellites. There have been so many launches. Launched French Guiana, the spaceport there, Kourou spaceport. And, you know, it is a powerful and successful launch vehicle. Due to at some point to be replaced by Ariane 6, and Ariane 5 replaced Ariane 4, which was less powerful. But not all launches looked like this. This is the first launch. This is probably about a minute after it launched. This is basically Europe's most expensive firework. It is estimated to have cost all parties around 380 million US dollars. It was carrying the cluster mission, 4 satellites, which were scattered over the forests of French Guiana. Basically, it blew up around 40 seconds into flight. The problem started around 37 seconds in. In fact, if you really want to read about this, there's actually a detailed report that was published the next month. So it was 4th of June, and 6 weeks later, the failure report was published. This is interesting historically because this was one of the first times that this kind of thing was made available on the internet back then. And what they discovered, what they determined, data at that time did not contain proper flight data. So there was something wrong between the systems, but showed a diagnostic bit pattern of the computer of the SRI. This is basically kind of the inertial guidance system responsible this part for launch control. And unfortunately, there was error data, and it got interpreted as flight data. In other words, you've got a whole load of bits that are basically something is not working, and here is an error message, and the error message is being returned as is being interpreted as values. That's not good. That's going to give you garbage, and the rocket's going to go all over the place. The reason why the active SRI-2 did not send the correct attitude data was the unit had declared a failure due to a software exception. In other words, something bad had happened, but something was not picking up correctly the failure. So in other words, a failure had been signaled, but not handled correctly. There was a paper in 2014 that basically did a study of a number of software failures with a very simple title: Simple Testing Can Prevent Most Critical Failures. They actually found that unit testing can be used to deal with about 3/4 of large-scale catastrophic failures. But what was interesting is that they also revealed almost all catastrophic failures are the result of incorrect handling of non-fatal errors explicitly signaled in software. So in other words, it's not that people aren't signaling and detecting the failures, it's just that they're not picking up the signaled failures, in other words, the thrown exceptions or the error statuses. So let's talk about how this came about. The software exception was caused during execution of a data conversion from 64-bit floating point numbers to a 16-bit signed-in value. For a lot of you, that you're just thinking, oh, that's a double to a short. And you're going like, well, that's not going to be a problem. If you're doing this in C, or you're doing this in C#, you're doing this in Java, this is all going to kind of work out. You know, if it's too big, then you just get some arbitrary value. But that's not the way that this is programmed. The Ariane rocket was programmed using Ada, and Ada has a reputation for basically checking everything. So if you have a numeric overflow, it doesn't just wrap around or give you an arbitrary value. It signals a failure. In fact, we can actually see the code. There was a talk done by a member of the team that studied this, un petit bug, un grand boom. You don't have to speak French to understand what this is saying. And they actually showed the code. This is kind of interesting. So this is Ada. The problem is it's actually not particularly good Ada. Even if you don't read Ada, you can kind of read it as general programming language. You can see the if statements and so on. So let's look at a little bit of the detail. The data conversion instructions in Ada code were not protected from causing an operand error, although other conversions of comparable variables in the same place in the code were protected. Well, let's focus on this. There was checking in other parts of the code for this case. Examples like this. And in these examples, what we see is that there are actually some issues with the Ada. The Ada is not that brilliantly written. You can just go through it, and you can already see that, you know, we've got hard-coded values here and here and here and here. And actually, you're kind of wondering, what does this mean? It means that that's a hexadecimal number. In other words, it's exactly the same value. So why they not only did they hard code it, but they hard coded it in two different bases. This is the maximum value or minimum value of a short int, a 16-bit signed int. So they're thresholding it. So why are they hard coding this? Doesn't the language know the size? Well, yes, it does. So in other words, you ask the language. Effectively, what we're doing here is basically looking at the integer max value and the integer min value, or the short max value and the short min value. If you're writing this in another language, you'd use those. Guess what? Ada has this as well, and it's had this feature since 1983. So it makes it clear that the people who are writing this mission critical code did not know the language. They also, this is duplicated frequently. In fact, this operation in other languages is what's called a clamp operation. So they could have easily extracted it and refactored it. Ada has inline functions to recover the efficiency. So what is interesting here is that clearly the people developing flight critical, mission critical software did not have the knowledge to write this code, and nobody was doing the reviews. So we can actually fix this, and that's all good. Now, what is interesting here is the other side of it. Some code did not have this protection, and this is one of the lines that did not have this guard protection. Is the number too large, too small? And this is the bit that made it go boom. So what's going on here? We can fix it. We can now put our clamp operation here. But why did they not guard it? They did not guard it because this code they basically didn't believe that there would be an overflow. This code is actually reused code. It's reused from Ariane 4. And Ariane 4 is a much less powerful launch vehicle. This is velocity handling code. The velocities are much smaller for Ariane 4, and so therefore they wouldn't have done. But when they reused it in Ariane 5, they did not do proper integration testing, and this was not properly documented as a failure case even in the regular unit tests. So they missed out on this. So there's a point here. We can borrow from the pragmatic program, a book of wisdom. Don't assume it, prove it. And we can also borrow their mantra of test early, test often, test automatically. There is good news, though. Some of the software did work. The software that worked was the self-destruct system. That's what caused the thing to actually blow up. The error caused the guidance to go off. And then you realize suddenly we've got a missile, and it's potentially dangerous. The self-destruct system, the software for that, worked really well. So good job, whoever wrote that. But there's another thing here. Remember I said it was reused from Ariane 4. Ariane 4 needed this code. Ariane 5 did not need this functionality. This functionality was now used by the ground system. It was not used by the rocket. So this is basically dead code, and they had simply reused the whole package and not rechecked it. Delete your dead code. Dead code is expensive. People often go, oh, it won't do any harm. Actually, that's not true. So let's look at another case to kind of help cement these ideas in place and kind of bring this to an end. CrowdStrike, Friday the 13th, if it's in hex. This is a biggie. This is a biggie. And it has cost. We don't know the full cost of it at this point in time. It has cost billions, absolutely billions. First I heard of it was people messaging me on social media. Perhaps the greatest Kevlin Henney event of all time. Hashtag CrowdStrike. Somebody else. Busy day for you, I suppose. Yes, it was. I got a lot of messages. I got a lot of tags, and then a lot of questions. Well, what's a Kevlin Henney? So CrowdStrike was a company that most people hadn't heard of before the 19th of July. And all of a sudden, everybody's heard about it. They provide security. They provide security software to make sure that you are basically not being hacked. And they do this for a variety of platforms. And on Microsoft, they use kernel level access. That's eventually going to change. Actually, Microsoft are going to do something about that and follow the same path that Linux and others have used for basically having a more containerized and safe environment. You really don't want to let foreign code execute in that. Really have to be very, very careful. And actually, CrowdStrike do have, it appears, they have a very thorough testing process. So we need to understand a little bit about what happened here. And they recently published kind of early August, they published an incident report you can find online, and they kind of refer to it as the channel file 291 incident. It's based around part of the product called Falcon Sensor, and it turns out that it's a kind of classic kind of buffer overrun off by one error. The sensor expected 20 input fields, while the update provided 21 input fields. In this instance, the mismatch resulted in an out-of-bounds memory read, causing a system crash. So this is low level. You are in kernel mode. This is basically you're basically writing C here. So therefore, you have no protection for out-of-bounds access. That basically caused the CrowdStrike software, in attempting to access an illegal location, it caused the kernel to crash for Microsoft Windows all over the place. Airline chaos, bank chaos, you name it. So I said they've got a really good testing approach. And we might say, this is a code fault. A lot of people, well, no, it's not code. It's actually to do with the config files that they upload. In other words, the code and the ifs and the whiles, that was all correct. The problem is the data that it was handling was not correct. It was not robust. And we often have a blind spot here. Here's a paper from 2016, Early Detection of Configuration Errors to Reduce Failure Damage. Their study, they said, they looked through a whole load of software failures. They said, our study shows that many of today's mature, widely used software systems, and CrowdStrike definitely qualifies, are subject to latent configuration errors, known as LCEs, in their critically important configurations. In other words, the configuration is broken. And this is like one of the oldest pieces of advice, or oldest pieces of wisdom I ever picked up in software. The oldest saying, if you like, GIGO. Garbage in, garbage out. The configuration was garbage. Guess what? The program executed garbage, and we saw what happened. Now, let's dig into this just a little bit before we close. There's a really nice piece by Dylan Ratcliffe on this incident. What it seems is they have one process for testing their code and deploying their code, but they have a different one for config. People have a blind spot when it comes to config. People think, oh, config, that's just configuration. That's not code. That's not part of my application. So I wrote a blog in which I'd actually touched on this topic. What then is configuration? It is a formal structure for specifying how some aspect of software should run. Wait a minute, a formal aspect, it's a formal structure for how software runs. I know what that's called. That's code. Configuration is code. If you've got JSON, that's code. You've got XML, that's code. All of this is code. It's not something else. It's written using a formal notation. It might not be your primary language. It might not be Java. It might not be JavaScript complete. It might not be C. But it's still code. And that's what we need to remember. You've got to test this stuff. Now, interestingly, there's another thing that we know. Is it turns out, and you can find this in a few other places, but quoting from Dylan Radcliffe's observations again, it turns out that the code in question, a thing called content validator that would check and test that things were valid, had actually been demonstrated not to be complete. And the configuration, they had actually had problems in the months leading up to the 19th of July. These incidents show that someone within CrowdStrike was aware that an outage like that of 19th of July, a kernel panic resulting from what would be considered a valid configuration, in other words, falsely branded a valid configuration, was possible. So what we learn from that is you've got to learn and listen to your clients. You've got to test your code, and your code includes your configuration and all your other project assets. Remember to put those under version control as well. So in closing, there's a lot of practices we can learn. We clearly learn, we know testing. Are you testing? Yeah, you're testing. Of course you're testing. But what is it that we are testing? Don't just rely on integration tests. Don't just rely on unit tests. Test everything. Okay. Make sure that you understand what is code and what can fail. Learn from other people's mistakes. If you read something about a security vulnerability, write a test for it to demonstrate you don't have it. If you hear about a class of bug you've never heard of before, write a test. Hopefully your system passes. If not, guess what? You've made a discovery and that's saved you a problem in future. Incorporate the lessons of the past into your test suites. Incorporate the lessons of the past into your practices. Things like reviewing, not just stuff like version control, but automation. Okay, understand there is this, because otherwise we are left with, unfortunately, the observation is that although history is this vast early warning system, and if we don't learn from it, we know that we're doomed to repeat it. But it does seem that not learning from it is a common human habit. I hope that's been helpful. Thank you very much.